under the um, the course material is basically uh, come up with like a certain question like that. Okay, so if you have any concern about a final exam review, just basically let me know what it is. So there'll be total 9 questions on a final exam. I will let you know after we finish covering chapter 5 and 13 today. Okay, so it's will be like a small part of it, but that will be the course requirement for stat 213. So I gotta have to cover it. So for those of you who received the degree, just let me know if you have any concern or any problem feeling it. Okay. It's a question. Yeah, no, the final exam will be 9 questions. This is what I told you guys a very long time ago, but I feel like it's really bad to give you 9 questions for each exam. So, but the final exam should be like pretty much exact same format that we have from the previous 3 exam, but there will be total 9 questions on it. Okay, so each question will be accumulating different points. Okay, so let's say the first question can be 5 points, can be 10 points, or can be so there are actually some question that will accumulate, maybe 15 points on the exam. I would say no, it should be the end of the date because I don't want to postpone to it. But I would say will be the end of, let's say, 10 a.m. because this is the time that I have to start grading immediately. Okay. So that will be after class tomorrow, next Saturday. So next Saturday gonna be December 18th. So the final exam should be available after, I would say after 3 p.m. Okay, so you can start exam immediately, but you can wait out for a while. So the final exam still be like 2.5 hours. It's actually 2 hours, but I feel like you guys doing a great job. So I give you 2.5 hours plus 30 minutes that you submit the exam on Blackboard. So let's say convert uh, the image file to the PDF file. Um, the grade sort of for the exam two on the Blackboard. No, I haven't really graded yet, but I think I was pretty headed to your grade, Brandon. So you're gonna give me some time, and I was definitely gonna finish grading it. So grading one exam gonna take at least like 5 to 10 minutes for that. Okay, so just be patient a little bit. I'm gonna get to you later on for that reason. But for the final exam, I will start grading the final pretty much on Sunday. Okay, on 19. So I will try to give you guys the grade for the final grade before Christmas. Okay, is that good? All right. It's due 10 a.m. on Sunday. Yes, that's correct. So it's due. It's kind of be. It should be like due at 11:59 p.m. But I feel like giving you guys more time to to complete, to study on it maybe, and then you don't feel confident to take the exam on Saturday, which is on December 18th. So you can't take the exam on Sunday. So, but the time that we should start will be around 7 a.m. in the morning. Okay, I feel like that's gonna be fair. Okay, so any concern before we start chapter 5 and 13 so far? Okay, so just be a little patient. If you can't come to office hour, I can definitely tell you agree, but you have to wait for that. So unfortunately, I'm sorry with that, but it take a little long to check the work, and just see the information that matches, and all things, and all information. Okay, are we good with that? Okay, so last day of class is today and next Saturday. The next Saturday going to be the three that we're going to take the final exams and do some review at the start of the class. So I might just ask you a question. How many of you going to ask me to do the questions on that review sheet, right? So each person might have like a few problems. Just tell me exactly what problem you want to deal with. Okay, so you can ask me just by email, going over some question, or you might just let me know what it is on the day of the exam review. I would definitely want to go over it, but you can't just ask me like so many questions, and you should give other people a chance to ask me the question to deal with on the final review. So that would be wonderful. Okay. So anyhow, any concern with that? I also tell people like the way that we compute the final grade. So this is the way that this It's very straightforward. So let's say the first exam you got 80 points, the second exam you got 90, this final exam you got 60, the homework you got 75 out of 100, and then this is what we're going to compute it. So the first, so the lowest grade of the final is going to be dropped. So remember, if you do really well in the first two exams, you still have to take a final, okay? You cannot skip it. You still have to take a final exam because the final exam is going to count double. So let's say whatever that you get, whatever the grade that you have. So let's say the final exam will be the lowest grade. I will subtract the minimum, and then we just add them up, all three divided by 3, and multiply by 80%. So all three parts are going to be worth 80%, and then the homework will be 20% from the website. Okay, so I already removed some of the question from chapter 11 for the homework. And all of that, I also extended the deadline that you can complete the homework by Tuesday. Is that good? On December 21st. So let me just repeat that again. Okay, so the final exams. So today gonna be like chapter 5 and 13. But before we start it, I really want to make clear what we have so far. For the class, the final exam will be on Saturday, right? From I would say from 3 p.m. until, I don't know how many questions that you want to ask me during the final exam review. If you ask me a few questions, we should start the exam around 2 p.m. or 3 p.m. All right. So if you have more questions to ask, so we would start the final exam a little bit late. Okay. Until I would say 11 p.m., 11 a.m. in the morning. It's I would say it doesn't matter to me when you do. Yeah, so yes and no. Absolutely yes, you're gonna get some points back from your classwork for sure. So you're gonna add points to the exam. So let's say you have like 5 point added to from the classwork. Okay, so you got like 96 on a second exam. So I'm going to add 5 points to your classwork. So that would be 101. But remember, so extra point will be removed from the grade system. You can't exceed 100 points on the exam. So you want to be fair. Okay. So let's say you have the exam is 62. So you add 5 points, you got 67. Okay. So if total classwork that we have is 5. I did the CW classwork. Oh, but I didn't need to use them. No, it's definitely not going to be something that we going to consider. Okay, it's cannot be moved. The points can be moved to the second exam. So when we started with second exam, I consider from the classroom number 4, 5, 6, 7, 8. Okay. No, not necessarily. The final exam again, that we can't really have any extra point for that. So we just want to be really fair. But I will consider some of you doing the classwork. Okay, so let's say you finish all the classwork. Okay, and then all of a sudden that you got like really high grade on the exam, and then the final exam you're not really doing really well on it. Okay, so let's say I got a first exams like 100, the second exam I got 98, something like that, and then the final exam I got like 72, whatever it is. So, and then I see the progress that you make is lower than my expectation. I feel so shame for you for that. But I see that you finished all the classwork, so I might consider adding like maybe maybe a little curve. But it's not going to be like a big curve for the final grade. Just want to let you know what it is, okay? And I also check the homework grade, that how much that you get for the homework, because classwork pretty much like the attendance. So if you finish it, I mean, even if it doesn't count to your first or the second exam, but it still be there. I mean, I don't remove it. So you just want to I just want to let you know that the classwork grade, I never remove any of them. I just want it to stay there until the end of the semester. I put that a final grade, and then the letter grade should be submitted after Christmas. No, it will not be added 5 points to the final exams and stuff. And are we good with that, people? I just want to make that clear. The final exams is going to be how much was the homework worth? I would say it's worth 20%. So let's say the homework that you get 75. So you have to multiply by 20%, right? And then you're gonna take the average of 3 exams, of course, so you have to drop the lowest one. If the final is the highest grade, so you're gonna drop one of the exams. So that is what I'm using the code, the minimum, okay? And then, and after that, we're going to multiply that by 80% plus 20% of homework. So we gotta find a grade of the, of about class. Okay, just wanna making sure that we understand this scenario. Okay, are we good with that? So almost like the last day of class, where people are getting really, really stressed out, really, really exhausted. I know some of you might have to take the final exam later on, but so remember, the final exam that we have will be on next Saturday, right? It starts from 3 p.m. until 11 a.m. in the morning. Yes, this is what I'm planning out to do. I think I removed some of the chapter 11, and then I checked the system that there actually some people got more than 100 points on the homework. It's still be 100. It cannot be the homework. It's gonna be more than 100 points for that. But for those of you who actually finish it, so I might just basically reduce the some question from chapter 11 and some question from chapter 9 as well. And then, so for those of you who leave that you have no clue what it is, just move on to the next questions, okay? And then I might get it removed from the homework system. So the final exam again that started from 3, and there will be total 9 question. Okay, so I just want to make myself clear. So this is going to be the thing that we have to deal with for the final exam. Okay, so it should be like straightforward, like from 3 to 6 p.m. But I feel like some people might not be ready to take the final exam. Just make it like, okay, tomorrow or something like that. Okay, so you can take it later on. Is that good for you? Is that good for you? Is that good for us? Okay. All right. So you have 3 hours, like 2 hours and 30 minutes plus 30 minutes for submit work. To submit work. Okay, is that good? To submit work on Blackboard. So making sure that you have to get your work done. If you miss the hypothesis from your work, you're gonna get point deducted. So make sure that you have to do like a lot of this. Like you have to conduct hypothesis and then compute the statistical values and the critical values. And then after that, we're gonna compare the statistical value and the critical values, right? So that's really important. So the material we're gonna focus on more on a later chapter. So we basically know the fact that it's started from chapter 4, right? So from chapter 4 up to chapter 13. Okay, so the 13 is basically or literally 1 questions on it. Okay, are we good with that? So any concern, but the material that we focus on will be a little bit more in chapter 6. I might not give you any question for chapter 4. I might give you some question on the exam review, but chapter 4 is like computing the final summaries and outliers and all of that. Mean standard deviation, so it's might not be on the exam. Yeah, no, it's definitely not on it. All right, is that good? Okay, so I feel like that's the way it is, right? Is that clear to everyone? I just want to keep this until the end of next Saturday. So the next Saturday is optional day, so you can come or not coming to the class. I believe you can just ask if you just like it's just like, well, I mean, I'm ready to take the exam, so you don't have to come for it, but you still have to wait until we can start the exam. Okay, so I feel like that's going to be working for us. Oh, I mean, I wish I could answer. I haven't really made up the question yet, and then it's literally not quite easy. And then usually it's something I ask me, which you put that reject and fetch reject. And then the next time I'm gonna be HO, and there's a lot of things going on. Yes, we do have the exam review on 18. So this day I will be devoting all of my time for you guys to ask me questions. Okay. All right. So let me just start up chapter 513 for today, and that's pretty much the thing that we have for the entire lectures. Okay. So chapter 13 will be called the sample and population regression model. Okay. So it's literally not quite easy at all when we first came to a SAM model like that. So the sample model is coming from chapter 5. Okay. And then the regression model is coming from chapter 13. So let me just let you know what about the chapter 5 looks like. So you will be given like 2 different data set, right? For instance, and then all we need to do is just gonna make a graph. Okay, so you're gonna have a certain comparable prices. So let's say I want you to look at the price of you know of I would say steak, for instance, right? In 2019, and then this is 2021, for instance, and then you're gonna get the prices. So let's say cost for each month. So let's say this is the month from let's say we start from July, and then August, and then September, and then November, and then December, right? Whatever it is. So it's a certain time period that we're gonna put in like some data set. So the average price, for instance, or maybe a certain price that we have collected from any store, maybe from Costco, maybe from Lidl, maybe from any other places that you can buy the meat. So of course that you have to use the 2-year period. You can't just tell me that, well, the store was bankrupt at the time that it come back on 2021, so that doesn't make any sense. Making sure the store had to be open until maybe at least 2021 in the December. So the price, as you say, for a certain pound for that would be around maybe $6, and then 6.5, right, for instance, and then this is like 6.2. So assuming that this is per pound and for a certain, we're gonna use, it has to be the same steak, right? So maybe 6.6 and then 6.8, for instance, right? And the price adjustment depending on whether or not they are, having some, good enough supply or not having good enough supply. So we gotta be careful with that. For the July in 2021, so because of the inflation's hike, so for instance, that you might see that the steaks going up from $7 to $7.5, and then $7.9, and then $8, something like that. And then you're gonna on December, so it's go up to $8.4, for instance. Okay, so it is what we have for a certain number that we're going to compare yearly analysis. So we want to put it on a system and then how it's going to work. So let's say we want to use the price in 2018 and predict, 2019 and predict the prices of 2021. So let's say the next year of 2020, in January, I want to see that going to correspond to the prices for the next year of 2022 based upon the 5 data analysis. Is that good? Is that understandable to us? N equal to 5, right? So when we capture all of this, so we're going to make a certain plot. So this is July, this is August, and then September, and so on and so forth. So let's say I will consider the X on 2019. This is what we're going to use for the raw database. And then I want to predict the prices in 2022. So it's at the year end of 2021. So this is the Y values that we have. So the X will be the raw data set. The Y will also be the raw data set. But what we're trying to do that we're going to use the price of 2019. So this is what we call the independent factor. It's okay, independent factor. To predict the price of 20 January 2022, right? So this is what we call the dependent factor. Are you good with that? Any concern for this? Okay. All right. So generally what we're going to do for the model is, of course, we have to make the scatter plot. The scatter plot meaning they're going to plot them for X and Y. So let's say this is the X, that $6 range to $7 range. So the range was $7. Okay. And of course, the scale doesn't matter that much. And this is from $7 and then to 8 hours, 8.4 hours. I mean, of course, when you do it from a system, it should be different, but we're not going to have enough space for it. So that'd be 8.5 hours. And then all we need to do is just going to plot them. So 6 is going to cost 1 to 7. So you're going to get 1 point here. So this point represents the prices, the unit price for both 2019 and 2021. Okay, so this point is going to give us the value of $6. So that we consider the X, and then $7. So that we're going to consider the Y. Okay, so those two values is coming from 2 different years of the analysis. So the same thing for that. So when we rose to 6.5, and then the prices also rose to 7.5 of the plots, right? And then the next part that it's rose from 7.9. I'm sorry, 6.2. So it's going down a little bit. And then this one is just go up to 7.9, so a little here. Okay, and then this rose to 6.6. Okay, so that 6.6 here. And then it's the prices rose to 8 hours. Okay, and then finally that it's go from 6.8 hours, right? And then the price rose to 8.4 per pound. So apparently that we're gonna have 5 different colors representing like 5 different plot of different months that we collected data from. So now our job is to look for the line that can matches all of this values. Does it make sense? So it looks like the years of 2019 is going up. The prices also going up because it's closing to the, Thanksgivings, or, we have a Thanksgiving, we have a Christmas, we have a holiday coming up. So the prices might be a little bit getting hiked, right? So in this case that we can realize that it has a positive correlation. So the correlation is just represent the strength that 2 or more variables are connecting. Okay, so if you have like 2 variable, the correlation that can be computed by the summations of each data point, subtract the X, that would be the deviations of X, the deviation of X times the deviation of Y divided by n-1. This is what we call the covariance. Okay, so it's measured directions of or relationship between 2 or more variables. Okay, I'm missing a few words here because we might have to compare like maybe from 1 year, from 1 to more variable for that. So let's say I want to predict the price of 2022. I'm not gonna graphing a single factor. I might graph like 3 or 4 or 5 factors. So I might graph different years and see how it's correlated to each other. And then you might have to remove some of the factor that will be irrelevant to the system. Maybe some of the factors that really go off the track. And then so we call the multiple regression. Okay, but we're not going to go deep into it, right? So we're not going to play with like many factors. So let's say I want to consider the factor of GPA will be counted by, will be affected by, by maybe the studying, the number of hours of studying for the final exam, and then also the number of work, right? So that we have to do, and then there are a lot of things that's might affect it. So the more things that you take, the better picture it looks. Okay, so when you only base upon a single factor, just like that, just this here, so this is what we call a simple regression model. Okay, simple regression model. So which is y equal to mx plus b. Okay. So there are only one y and one x. Is that good, people? Is that good? So is that understandable to us? So what that means is that so the x will be treated. So we're going to use the value of x to predict y, right? Use x. We use x to predict y. Okay, so that's going to be a thing that we have to put a little hat on top of this. So the little hat here, the value for the hat is different from the real value that we get from the system. So assuming this is the line that we have, like y equal to, let's say 0.5x plus whatever the y is, right? And then plus b, whatever the b is. So what we're going to look at, so this is what we have for the predicted y. So let's say we go into the same x, right? So assuming this is x equal to 6.8 right here. Everybody sees that? So 6.8 going to be the value for x, right, for the system. Okay, so that we're gonna look at the value, the corresponding value for y is 8.4, right? So the real value that we have will be 6.8 and 8.4, right? So this is what we have for the raw data, right? The raw data sets. So the prediction for y, for instance, the prediction for y is different. Okay, so the y, so what my x equal to 6.8, the predicted y is actually not equal to 8.4. So when you look at on the chart, so assuming this is the best line that we have, so the value for y, I would say will be right here, right? So the point when x equal to 6.8, I want you to look for the y value. So it might be equal to, let's say $9, right? So there'll be $9 on the system. Does it make sense? So assuming this is what we have in the graph. So this is have to be equal to 9 instead of 8.4. Okay. How we go with that? This. Okay. The difference that we have from here, will be called the, I would say, it is what we have, what we call the residuals. Okay, residual. Okay, so the residual is basically a difference of the predicted y and then the real value of y. Okay, so this is what we have for x, and this is what we have for y here. Of course, that we're not going to spend too much time working on it, but the definition of the residual would be the observed, subtract the predicted, and then we're going to compute all of this. So let's say the observed that we have, all right, so when x equal to 6.5, and then the y was 7.5 right here. So this is the real value for x and y, but the predicted value for y that we have from the system is not actually equal to 7.5. It should be slightly like, it should be slightly equal to 8 point something, right? No, y hat is a predicted values, predicted values. So y hat is the predicted values based on the x. Okay. Based off the x. Okay. It's different. It's not. So first of all, that we need to have the y, right, and to make that prediction. But finally, that you realize that the predictions you want to see how far of the prediction from the real analysis. Okay, so the far off is basically we call it residual. Okay, and if you ask me how people came up with this line, it's generally not going to be covered in this class. I'm not going to ask you like to compute uh you know all crazy things like looking for the sum of the deviation of x times y over n minus 1, and then you're going to compute it by the correlation. So the correlation just represent the strength uh, of the analysis, right? The strength of the two or more variables. Okay, so it's sometimes bad. So the r, the small r, is bounded between -1 and 1. So it's, I believe that's going to be a thing that we're going to look at. So bounded between -1 and 1. Okay. So if you ask me why it's bounded between, why do we need to do that, and why don't we just use the covariance? The covariance give you direction, but the correlation is going to give you the strength. Okay, if they are perfectly correlated, it's going to be equal to r equal to 1. So when r equal to 1, it should go like this. They should travel in the same direction. If the correlation is very, very strong, but it also go down from the left to the right, so it has a negative slope. So it means that they are negatively perfectly correlated. If you might have some weak correlation, it means that no matter how you're gonna use the line to sketch them, there's no way they can find that relationship. So meaning that it's the correlation with always equal to 0 or equal to 0. When you have like a different models instead of like the linear, so remember the summary questions that we have is focus on the linear lines. If for some reason that you plan on taking some high level statistics, so you might have to deal with the polynomial regression models, and after that, I'm going to jump to the log linear regression model, which is a little bit higher advanced level of our class. But it's again, it's definitely have to come back to linear. The linear always be the most basic, and the basic thing is always the most important thing that we got to focus on. So if you have like a certain model like that, it's still be equal to 0 because it doesn't follow the linear curve. Okay, and you might have some strong positive correlation, you might have some weak correlation. So all of that is based on the data set points. I don't know. It might be. It depends on what it is. So you might have to study like yeah, I would say so. It depends. We also have like stochastic process. We also have the the multiple regression models, and but the Hunter College doesn't have the course called machine learning concept. It's the first chapter that we're going to continue on this part, and then how the machine's going to predict a data set, right, based on that. And of course, it's now going to be the final story for it, but we're now going to, I would be considered a weak correlation. I would say something that is lower than 0.8 would be considered a weak correlation, but it also depends. There are actually some data set that low, that even higher than 0.9, still considered a weak correlation. Okay, there's a lot of subjects that they might have a certain gap. So let's say one of the point that fall off the track, just like that, and then it still make a perfect line. So you might put that into like the outliers. You're gonna keep them and then treat them differently. There are certain models, and then that you might have to consider removing it from the regressions. Okay, so it still gives you a very, very good strength of the correlation. I would say a good strength of a correlation, but it's sometimes doesn't really reflect to the general model that we're trying to develop on. Yeah. Introduction to mathematical statistics, that course, I would say those things are different. I can tell you this, most of this course at 300 level and above, something like that, we're not going to study something new. Let me tell you this. Okay, so the stat 213 is almost be like the last level of statistic, except for the last chapter that we studied right here. So we have like time series model that we're gonna look for how the thing gonna change periodically. Okay, so there's a and then we have yes, so, stochastic process, how things going to test on different aspect of the model. It's not hard depending on how good you are at statistics, okay, at math. So what we have done so far is just plug in a value and get a forms. But when it comes to, I would say, stat 313, you might have to prove something. You're not going to do something like, well, I'm going to give you the X bar one, X bar two, or I give you a bunch of data, so you're going to compute them. No, the question would be like, how the heck that you can get this form? So you're gonna prove it. Okay, you're gonna prove what the difference between the confidence level and the hypothesis testing, right? So it's basically coming or deriving from the same concept, but the fact is that we treat them differently. We use different tools and different way of interpreting the data sets, right? So the confidence interval doesn't necessarily give you any bow. It's just going to theoretically tell you this is what it is, right? So the hypothesis testing, you have to assume coming from the no hypothesis is some, and then we're trying to disprove it. And I would not say it's hard, but it's all based on the probability concept. Okay. And then there will be some math tools that we have to play around with them. All right. Anyhow, I just want to stop here, and then we're going to move up to what related to the question that we have in the final exam. I feel like that's going to be good enough. So for the next part that we can literally check that I'm using StatCrunch. I'm not sure how many of you heard of it. It's has been used for map for stat 113. I would say this sucks, but it looks pretty good because it's give you some very knowledgeable information coming from the lines that we have dependents and independent variables. So and adding that, it doesn't really work out really well. So, and then we also have to test on certain things, whether or not we can use this line and not using this line using a t-test analysis. And of course, this is going to be a thing that we going to skip. Are we good? So we finish it. Chapter 5 is done. Any concern for that? Any questions regarding it? No question. I don't want you guys to I don't want to see you suffering like from doing all of these COVID. So I skip the chapter. I feel like I better skip the chapter. It's not quite easy. I mean, it's not hard. Just like I need to compute the slope by taking the correlation time, the standard deviation of y over standard deviation of x, and then I'm looking for the y-intercept by subtracting from the x bar and so on and so forth. Okay, I agree with that. No, it's not going to be in a final exam. So the total variations, what is the total? Let me just spend a little bit of time explain it for those of you who want to like move forward. But if you stop right here, then we just stop right there. And for the total variation that you sort of feel like, what is that one? So this is, anyone still remember how we computing the sample standard deviation? That we need to take each data set, subtract the average, and then you have to square them, right? Remember that? So you're gonna take each data set, right? Subtract the average, and then you square them, and then you take a total. So we call and then you divide it by n-1, right? And then you take the square root at the end to get the sample standard deviation. So the total deviation is basically what we have for the total variation. So that's what will be different. So assuming that, so we had to compute it the x bar 1 and x bar 2 for each data, right? So we're gonna add them up. Sorry. So this is x bar and this is y bar. Okay. And then, so let's say we can compute all of that. So the x bar, we add them up divided by 5. I don't know what it is. So it should be on a line for sure. Okay. So assuming this is x bar and this is y bar. Okay. X bar, y bar. So if you can help me, I can do it a better shape. But it's we just add them up divided by 5 because we have 5 data, right? And then so the total deviation is just going to, so we have to take each data point, right? Each data point. So this is a data point like 6.8 and 8.4, right? Subtract the average and square. So we gonna get this total deviation, right? And then, yeah, correct. Y, what's Y bar? Yeah, the Y bar is the average. The average is always be the, it's really hard to tell you, but it's always be this, the unbiased or the non-biased estimator, right? So you always use X bar when you compute the confidence intervals. Remember that. And if you ask me why, it's really hard to show you why insufficient statistics. So the people already prove that the X bar is the unbiased factor that we can utilize, and it's have to be analyzed for that reason. And then so we can get the total deviations by adding the explained and unexplained variations, and then I'm gonna get the final answers for that. So total variation is going to be the sum of the unexplained variation. So that's going to be the difference of, each data points coming from the predicted, and the explained variation is going to be, the predicted until the Y bar. So that's going to be the things that we have right here. And then we're going to add them up and you're going to get total variation. So all of this is going to reflect the strength of the data. Okay. And then when we do all of this, and then we're going to compute the R square, which is called the coefficient of determinations. And then that's going to be the ratio between the explained variation to the total variation. So let's say if the R square equal to 85%. So what does that mean? So meaning that there will be 85% chance of the data, or 85% of the data is connected to our regression model. It looks really cool. It looks really cool. Okay. And then this R squared, basically we computing by looking at the correlation square as well. So they must be the same. Okay. So let's say R square going to be the same as we're taking a correlation square. Okay. So this is how people develop the tools. And then, and I'm not going to prove the equation. I actually did prove once when I taught the calculus-based statistics. So it's sometimes it will be different. There's no number that we evaluate. We just do our proof for that. But generally, we're not going to spend time working on something that relevant to the exam question. So I might just stop chapter 5 here. Then we're going to move forward to chapter 13. Are we good? All right, so chapter 13 is different. So we're not going to use the, no, it's not like that. It's the R will be computed by, it depends on what you're looking at. So if you want to compute a correlation, and the R square is going to be, that one will be the covariance square over the center. Yeah, it's sort of similar to that. The covariance square over this, the variance square for X, the variance square for Y, and the same thing for when you're computing the residual. We just interpret it differently and see how it's going to relate it to the data sets. Okay, so if the R square was very small, so let's say you got the R square equal to 0.02 or maybe 0.5, even the 0.5, that when you take the square root for that, it's basically radical 0.5 is actually close to 0.7, something like that. So when the R is close to 0.7, it's actually not really good. It's actually not really good to use the linear model. So you might switch them and use different models to predict those data sets point system. So the goal of statistics is trying to find a pattern that get the data work. Okay. And it's not quite easy to do so. There's a lot of tools that people can utilize. One of them is the linear model, right? So And another of them that we're going to consider is the polynomial model, but all of them have to come back to a log linear later on. Okay, and then if things changes periodically, so we're going to have a time series model and so on and so forth. Okay, so I've been talking too much for that. Now we're going to move up to chapter 13. So chapter 13 is literally not going to be a lot of difference compared to chapter 5, but instead of we working out with the sample, so now we need to work on with the population. So what it means by that is the fact that we're going to look at the population model compared to the sample model. So this is a population model. So the whole things that we're trying to do for chapter 5, we call it data analysis, right? We're just doing on the data set. We definitely not going to do anything that relates to statistics, correct? So when you only play with the sample, that, you know, and then we do not come up anything regarding to the population perspective. So we just literally call them data analysis, correct? Data analysts, so all of them. So in order to be the statistician, so we must use the sample and see how the sample is going to reflect the prices of the beef or steak, right? For those 2 years. Okay, so we're going to take the sample of 5 months, and then I want you to come up with the entire population, the entire beef prices in 2019 and compared to the prices in 2021. Okay, so sometimes it's really, really hard to gather all the information on those 2 years. And especially when you have like different prices change day by day, so that even harder to collect them. Okay, so and so the fact is that so the population is going to help us determine the models a lot better. So the model for the population, of course, that we're going to use the alpha and then the beta. So the alpha is literally no difference as the y-intercept. The beta is no different as a slope. So, but the reason why people use those two things because it's working on the population. Okay, the population perspective. How we go with that? So what that means, and the most important thing that we're going to deal with for the population is that it's going to come with the error. So remember, the error is very, very important. It has to be a consistent error and is not, and is basically inevitable. So there's no way you can avoid the error bound when you're trying to utilize the sample and compare to the population. The errors always exist, right? We computed the margin of errors of a sample of the population to the population by itself, and then we evaluate it from chapter 9 and chapter 10. Yeah, better the slope. And I don't think that it's really matter that much because on the exam questions, I would definitely gonna give you that line. So the only thing that's really important that I really want you focus on is that the alpha plus beta x and then plus the error. And if you ask me why do you always use some Greek letters for the population, I don't know. I mean, the epsilon is, why do you use epsilon? Why don't you just use E to represent the error bound? It's gonna be a lot better instead of using epsilon for that. I was like, well, I was born late. So people use all the Greek letter to describe the ambiguous population. So we don't have information on the population at all. So those things should be a little bit vague, a little bit hard to understand. So they use Greek. So the error bound is basically the difference between the population and the sample. So remember, the sample doesn't have the error bounds here. The error bound that we go to a different perspective when we analyze the residual, when we compute the total variation to see whether or not the lie is going to fit into the system, right? But when it comes to chapter, so let's say assuming that the lie fitted, but now we're going to use this line on the population model. So it's now quite easy. So this is the error is not about the error bound that we have from each point coming to the line. This error bound is just represent the error difference between the populations and the sample. Does it make sense? Okay, so and then one thing that we going to realize about the fact that the error bound is, unfortunately, it's basically follow the normal curve, right? Normal curve. Yeah, so it's had been proven. And so using that information, we can also compute the average. So the mean is always be the central. So the population mean that we use these letters, correct? This is what we have to use for population mean. The y is will be the fixed value. So that would be equal to the alpha. So when it comes to the average, there's no errors that that actually consists on it. So right, so we're going to take the mean plus that or x. Are we good with that? Are we good? Okay. And then it's going to give us the standard deviation for y as well. So standard deviation for y should be given. And of course that people can test this out, but we're not going to spend time, to deal with them. Okay, so this is the mean value of for a fixed number of x. So it's become very, very ambiguous. But when it comes to like some problem that you're gonna be able to understand it. So the most important part that we understand that if the error bounds here follow the normal curve, right? It's important. We learned it before. We learned the sample standard error x bar also follow the normal curve, and then we can apply for the entire transformations, correct? From chapter 7. Still remember? Still remember for that? And then we can apply the transformation because of that. We can also apply the transformation of the z-score because follow the normal curve equal to, instead of we using the x, we're going to take that y values minus the mean for y and over the standard deviation for y. Okay, so that's going to be the whole story of what we have right here. All right, so let me just go over a few questions and see how it goes and how it's going to relate to this chapter. So let's take a look at the question number 1 that we have for the problem. Assuming that it's a simple linear regression models. We're now going to work with like 2 or more variables. That is just way too complicated. Okay. So the x represent the number of fit, and then the y is going to be the prices for the house, right? So for the large city, might be the New York City, I don't know. So the population regression model line is basically equal to y equal to 23,000 plus 47x with the standard deviation equal to 5,000. Are we good with that? So let's take the y equal to 33,000 plus 47x. And then also the standard deviation is coming for the y as well. So I'm going to put this down as 5,000. Are we good with that? So now the question is, what is the average price, the average change in price associated with 1 extra feet, 1 extra feet of space compared to the prices of the house changes? Anyone? So when x increased by 1, what happening? When x increased by 1, what do you think? Yeah, so the y is going to increase by, so the price. So for every single fit that increase, the price is going to increase by $47, correct? Does it make sense? Well, at your feet that increases, so the y will be $47. Is that good? Is that good, people? Does it make sense to us or no? Yeah. So why is that? Because the change of x we relies on the slope, right? So the slope represent the factors of increase, the ratio of the increases, right? So for every single feet that you increase, the y is going to increase by 47. So let's say x increased by 2 feet, so the price is going to raise by $98. I'm sorry, $94, and so on and so forth. Are we good with that? So the same thing for this. When x increased by 100, how much y is going to change? So let's say we add another 100 feet into it. So the price is going to be, I know it's been like a long question, but we're still using the same concept here. So when x increased by 100, so the y will be 4,700. Are we good with that? So it's just the same thing because the slope m equals to 47. Are we good? Are we good with that? Part B. Okay, so now the question being asked is not about the increases. So we want to see if, yes, so we want to see if, like, what are the chances that the 1,800 square feet of homes going to be priced over 110K, okay, or under 110K. Does it make sense? So usually that when people collect the tax of the property, so they're going to based off the prices of the local areas in your local areas. So they need to know how many square feet do you have in your house before they can estimate the price. Okay, so for that part, and then the chains that we're going to use, so the information that we're going to get, basically the square feet, and then the thing that we're trying to evaluate is going to be about the money, correct? About the prices. It's not about the square feet at all. Why is it sigma y, by the way? It's actually in terms of the prices. The x is just a factor that we're gonna use, as x will be the independent factor. Okay, so the prices of the houses generated by the square feet. Okay, for this question only. Okay, sometimes people related the prices of the house by the inflation rate, the price of the house by the local areas, or the local prices of shoppings or school and so on, so forth, hospital, whatever it is. But in this case, the prices directly reflect on the on the on the on the square feet that we have right there. So okay, so now I want to evaluate for the p of x, I'm sorry, of y less than 100K, right? 110K. Are we good with this, people? Is that good? Right? So we want to see, like, what are the chances that the person's going to get your house price over 110? I'm sorry, price over 110K. Is that good? Of the 1,800 square feet homes. Does it make sense to us? Yes. So now we need to look for the average for y, right? So the average prices with 118 square feet, right? So this is going to be the average price. It's going to be on the population. It's like all the houses that we have for that city. So that would be equal to 23,000 plus 47 times 1800, right? Are we good with that? Are we good? Yes. And when we compute it, what is the answer for that? Okay. No, it's gonna be that small though. It should be something really big for that. It should be. Was it? So let me just do that again. So let me just take 2300 plus, yeah, plus 47 times 1,800. Okay, so we got the prices as 107,600. It should be close to like 110. And yes, so that's gonna be the answers. No, that's perfectly cool. And we gotta get 107,600. Are we good with that? So the average prices for 18 square feet houses should be worth at 107 and 600K, right? So 107K and $600. Is that good? So this is the average prices. So we don't know exactly what it is, like how much that's going to work for your house, but we want you to see the chains that the house is going to price over 110 will be what will be. So we're going to compute the z-score, right? So the z-score would be equal to what? The z-score going to take the y, which is 110, right? Minus the mean. So the mean was 107,600. We just compute it. Is that good? Over the standard deviations. So in this case, that would be the standard deviation that we got is 5,000, right? And then we just compute it. And what is the answer for that? So we have 110, subtract this over 5,000. 5,000. Yes. So we got the answer was 0.48, right? And after we get the z-score, we're gonna do exactly the same things that we're gonna, yeah. So we're gonna get it to the charts, right? So 0.48, we get it to the charts, and then we can figure out the final answers for that. So hold on a second. Oh, I think so. Oh, I'm sorry about that. Just okay. I'll try to look to the chart real quick for that though. Just give me some time. This question from chapter 13 is not from chapter 5 because we're working on the population. So when it comes to the populations, it's always in terms of the Greek letters. Okay, so when it comes to the populations, always in terms of the Greek letters. And so this is what we have for population parameters. And the reason why we can do that because the error bound without proving is follow the normal curve, and then we have to use the transformation along the way. You're very welcome. Oh my goodness, it's gonna take forever. I might use another laptop. I have another one that's I do not really have enough information for that. So let me just go to the chart. Let me just download the chart real quick. All right, so I downloaded 7 times, and you just go to table number 3. Oh, 3A is correct. So the answer was 0.48. So we got the answer, which is 0.6844. Are we good? Yeah. So we subtract like 1 minus 0.6844. So the answer would be 0.3156. Are we good with that, people? Any concern for this? Any question? Oops, I'm trying to copy that part. Okay, looks good. Yeah, we're gonna do the same thing for the probability of the y is greater than. So remember that we're interested for the prices of the house. You're not gonna care about the fit, but the question is based off the uh, how big of your rooms or how big of your places. So you have to use the information for the fit of the 1800 square feet. And then we're going to do the same thing for that because the mean is going to be the same. We're going to do the transformation for z equal to, we're going to take 100k minus 107,600. I just want to make sure that this is the average that we computed. And then we divide it by 5,000, right? Correct. So the answers for that will be, yeah, negative 1.52. Start with that. So that we're gonna read it on a chart. So again, that we're gonna use table number 3 instead of 3a because the value is negative. So negative 1.52 is 0.0643. Let me just copy and paste real quick for that, just making sure that we got this right. Oh, it should be less than. Yeah, I'm sorry. Under 100,000 should be less than. I'm so sorry, but that's just slightly. Under is less. Yeah, yeah, I'm so sorry. There's a lot of things here. And then P of the Z, right? And it should be less than that. Less than 100K, which is negative 1.52. And the answers for that will be 0.0630. Any concern for that question? Are we good? Are we good with this, people? No, less than we don't subtract from ones. We only subtract from one when the size is greater than, right? When the size is greater than something. So given by the keywords over is greater than at least all of that. So we have to subtract from one. Okay. Oh, you forgot it. That's fine, but don't forget it on the exam. So you got to be careful with those. Okay. So remember, the questions is what? The questions going to give you a certain thing that they're very comfortable to give you, okay, for the X. And then, of course, the question that we need to estimate the prices of the house, right? So the chance that the house is going to be priced over 110K was 31%. The chance that price under 100K will be around less than 6%, around 6%, right? For 1,800 square feet. Okay, so this is what the question looks like. Are we good with that? Are we good? All right. That's it. I finished chapter 13, and we're gonna practice more question. Is that good? Oh, you want me to make it harder for you guys or no? I feel like that should be good enough for though. There's no unit. They do have it. So yes, so there's no unit for probably. The probability has no unit for it. Yeah, the proportion is like 6%, so and 6.3%. There's no unit for that. This is just percentage. This is the change that you're gonna get the houses prices over or under for certain prices that we name it the question. So it doesn't really have any unit for it. Okay, so let me just start with this questions. I believe it's all right. Okay, so we do the same thing for that. So the y will be 0.155 plus 0.007x. Are we good with that? Are we good with this, people? The question must give us the x. The questions gives us the x, but we don't know what it is. But the standard deviations, remember for the y has the normal distributions, and of course it's going to give you the standard deviation, so it must be the standard deviation for y, and has a normal distributions, right? And then the mean is this, and the standard deviation is 0.005. Okay. Are we good with that, people? Are we good? And then, and what is the mean for the coil X that are 15 milliliters in length? So we need to look for the average, right? So the mean for 15 will be equal to 0.155 plus 0.007 times 15. Are we good? And then you're gonna get the answers, which is, oh, come on, help me out a little bit. Final date, final exams coming up. Today, the final day of class is like, time's running so fast. We're gonna say bye to each other, and no time to take a break for that. Yeah, you're gonna say bye. You're gonna say, hello, this is the first day of class. I still remember the first day that I went over like a lot of concept and statistics, and you guys were like, what the heck was going on? It's like so many things that we covered for a single day, and then all of them is now going to be on the exam on the first and 2 chapters. All right, so oh, I'm trying. Maybe at least you're gonna learn like how to enter the number faster for my class. Yeah, so we're gonna do the for 17 is gonna be the same, right? For part B, let's do part B. This is part B. This is a trick question. The probability that y is greater than 0.26. Okay. Yeah. So for 17, we skip them. Okay, it's just 0.274. Okay. Yeah, something like that. It's okay. Is that good? You can just put it that way. It's just plugging the value. So plugging x equal to 17 into the linear lines, and you know what it is. So, and for part B, we're going to take 0.26, and then we're going to anyone knows what the answer is without doing the transformation? What is the chance I can get more than half the means? Right? It's 50%, correct? 50%. Right? If you know, because the z-score equal to 0, and we convert it to the z-score equal to 0, so it's have to be 50%. Does it make sense? And over 0.05. You don't necessarily have to do that though. And it's 0. And then something that's greater than 0 is 50%. Are we good? Any concern for that? Any question? It's just like that. So the mean for y was, so this one is 0.26, right? Something greater than 0.26 should be 50%. Okay. Is that good? Or you can just read on a chart. So when you look it up on the charts, so if you get like 0.00 is right here, so that 50% or greater than or less than 0.00. It's still be 50% for that though. It's still be 50. All right, so for part C, we're gonna do the same thing for that, but you're gonna look for the mean equal to 14. So we need to compute differently, right? So the mean for Y, so remember the X is no longer equal to 17 or 15. So the X equal to 14. So you're gonna plug that in. So the 0.155 plus 14 times 0.007. And you should be able to get the answers as .253. Are we good? Any concern for that? And then you want to look for the chains, the probability of the Y is greater than 0.252, right? The keywords right here, greater than 0.252. Okay, is that good? And then all we need to do just convert to the z-score. And then we just evaluate it. So we're gonna take 0.252 minus 0.253 over the standard deviation for Y was 0.005. We're gonna do like extra step like we just did from that chapter, so that 0.005, and the answers for that is 0.2, correct? Any concern for that? Sorry, negative 0.2. I apologize for that. After we get the z equal to negative 0.2, right? We're gonna look it up on the chart, right? So we're gonna look it up on the chart, and for the negative 0.2, right? And then you're gonna figure out the probability a lot of ways on the charts. So it should be something. Negative 0.2 is up here. Right here. Okay, I would agree with that. So that'll be like 1 minus 0.4207, and that is 0.58, 0.5793. Any concern? Any question? I would agree with that. All right, so that's pretty much it. So lesson 0.254. So you're gonna compute it by yourself. It's symmetrical. It's symmetrical for that. So when you're gonna do like positive 0.2 and whatever it is, so the p of the y of less than 0.254, you're gonna get the same thing, which is 0.5793 for sure. Okay, it's symmetrical. It's symmetrical. The curve is symmetrical for that. All right, so I believe that's pretty much it for chapter 513. Any other concern, any questions regarding the chapter summaries, or any questions regarding the homework or whatever it is? Are we good? All right, so that's it. That's it. That's the whole course. We'll finish it. We just finished chapter 513. And we just finished the whole course. So we're gonna see each other one more time next Saturday, correct? Before we leave, of course, that we're going to spend time on the final exam review. Okay, final exam review. And I'm going to spend like half of the times here. I'm going to tell you what kind of topic that you should focus on, okay, on the final exam review. Are we good with that? And then I will let you go after it. Okay, so the first that we should know how to do the final summary, but I highly doubt if it's going to be on the exams. like and then the outliers, the interquartile range, and so on and so forth, right? Outliers, whatever it is. And then we also have like the mean and standard deviation. But I highly doubt that might not be on the exam for that topic. Okay. So part two of the exam question. What do you think? What I should put on it? Anyone? Or I just give you one question and that's pretty much it. The final exam questions. One question. That's pretty much it. Be happy. Yeah. Can I do that? That's gonna be you basically take a high risk. You're gonna take a high risk. Yeah, the risk that you're facing is huge. If you don't know how to do that questions, let's say give you multiple choice question. One question is multiple choice, A, B, C, D, and then you choose it. That's it. Pass or fail question. You got it wrong. That's fantastic. 0 promise. Something easy. All right. I would say as come to chapter, the 75 is not going to be on the exam. I'm not going to ask you like to evaluate the correlation. So I don't even put data forms on it. I just let you know what it is. So the topic number 2 that we have on the final exam should be something that we are very familiar with, right? Something that we the probability concept, right? So still remember about the conditional probability. Right? So like and or, right? We're gonna deal with the and or whatever it is, right? So addition rules and all kind of things. I thought it was easy for you guys to do it though. Like it's really just seems to be very straightforward and yeah. And about that is I would say I think I just skip question number 1. So this is optional. I think I'm not going to give you that question on the exam. I think optional. Okay. So and or yeah, and you might have a certain things like with a table, right? With the table things is going to be on a chi-square. Are we good with that? And I just want to remind you, this is what we have, like independence, right? Independent. Correct. So right, if 2 events are independent, so what should we do? The 2 events are independent, what should we do? Right, and then it's definitely going to be on the exam for that though. So still remember what it is? You guys still remember what it is? Right, so conditional probability, so we have to look for the and equal to the conditional times the given, right? Times multiplied by the given, and then add them up and subtract them at the end, and then the independence is basically going to ask you to play well with some like, so let's say the change that you can book a ticket this November is 5%. So let's say the person is going to receive 10 calls, and then the change that is none of them is going to book a ticket. So we should be able to evaluate the independence probability. Okay, so the third topics that we're going to have, of course, is going to be on continuing on the Bayes theorem. So the Bayes theorem is a very important theorem, but I might not give you this theorem on the exam because I feel like it's not hard. It's just something that you have to make a chart. It's optional as well, but there's no guarantee that I might not give you this, but it's a very important topic for that. Those optional. Okay. So 3, expectation. Right? Expectation is something that we have. It is also optional for that. We're not going to spend too much time just working on this, right? Expectations. I can't even remember what the Bayes theorem is. Remember the chart that we built with, right? And then so of some things, and then you're gonna put out 100%, or maybe you can have like we can have this, right? Something like that. even by two things. Right? Still remember what it is? The branching trees and so on and so forth. So we also have, but you might have something that we dealing with the Z transformation, right? Okay, the Z transformation. And then we also have a topic that we call the inverse transformation. I feel like inverse transformation is a very important topic, so you might see this question on the final exam. Okay, is that good? And topic number 4 that we're gonna use, we have done it before, right? We're gonna compute the Z-score by taking the X bar minus the means over the standard deviation, right? And then times radical n, correct? So we have this one, correct? So, and then we also have the Z-score, which is equal to the P. So we have this question on second exam, of course, that you might have another question on final exam. I don't know, I might give you the same thing, but it's just, so it's just have to be consider like which question will be on it, right? Correct? Are we good with that, people? Are we good? Any concern? Any questions regarding it? Are we good? And then question number 5. Topic number 5, of course, that we're gonna see some confidence interval, right? Confidence interval, and like for T or P, right? For T, and for P, right? Correct? That still be topic number 6, right? So we spend times on the t-test, right? The t-test, we have this question on second exam, so we're gonna put that at X bar minus the means over the standard deviations times radical n. Okay. So you might have the same, you might have different question for it, but it's still be the same thing that we have for P, but it's gonna be something that we play around with them. Right, for Z's test is P minus P hat minus P over the square root of what's, right? The square root of P times 1 minus P over N. So we haven't really have those two topics on the second exam. So so we should be focused more on those two topics, right? Are we good with this? Topic number 7. And we know the fact that it's we have the T, right? So the big form is for T, right? The big form for DF. And that's something that we have to compare the means, right? And we still remember what it is, compare the means for T, right? So we have both of these questions on the exam. I know most of you don't like the big forms for DF. It's just way complicated. I understand, but it's still be one part of it. So we have this part over over the standard deviation times radical n, something like that, correct? And then we, in the course that we're going to focus on topic number 8, which on the chi-square parts, right? So the chi-square for multiple proportions, like for goodness of fits and independence, correct? So those are two different topics. And for independence. Okay, so I don't know which ones is going to be on the exam, but I feel like, so topic number 9, we just did it. So compute probably. using y equal to mx plus b, right? All right, so any other concern for those 9 questions that we have here? Any concern? Yeah, I'm trying to go for it. So Eddie, so would you mind to come over to my office hours maybe next week? But if you can just email me, I will tell you the grade I will grade. There are actually around like 10 more people that I haven't finished grading, but I will do the rest of them at the end of the day. But hopefully I can do it after class if I have times. Yeah, so I still have a lot of time. I will try to grade, but I do not guarantee I will grade you. I have to go in orders like this. Okay. Is there a way I can review office hours, Sophia? Office hour. I was there waiting for all of you. Only 2 people came. Okay, from 12 to 1 p.m. But if you want to review the second exams, would you mind to go to the office hour um, after class, right after class? So I will be there for like 10 minutes before I finish the grading for all of you. Okay, is that good? So we go to the office hour link after class. So I'll be there for like 10 to 15 minutes. Okay, and then if you want to see the grade, you don't know what you got from the second exam, so just you have to wait though. Like each exam have to spend maybe at least 10 minutes for it. Okay, Manor. So I'm so sorry, but I tried to accommodate, but it's I'm so sorry about this. So I would say get the question for practice. Oh yeah, that's a good question to ask. But it's going to be. I might let I might grant you access to look up the exam. Is that good? I might grant you some the access so you can view the questions and or you can store for one attempt only. You can just to look up on the question. Is that good? Okay, so I would do it. I would do it. So and yes, so so that's the lowest one. So I'm so sorry. I wish I could do anything for you. So what is expectation? So the expectations might be the optional. Um, I might need more than 10 minutes. Can we reschedule another day? Okay. How long do you want to stay? I will be there. I will be there to grade all the exams. So hopefully it's yes, hopefully I can you can stay there for sure. Okay, but making sure that one by one because I want you to look up the exam. So if 2 people come and say I can't share the exam with you, okay. So for some reason, if there are more than 5 people coming to the class, so to the office hour, so I might ask you to leave for like 10 minutes and come back later on. Okay, so I mean all of you can join, but just let me know if I can go like into position and position. Okay, I will meet one of you one by one for that reason. Okay, so Safira, so go to the office hours and then we're going to talk a little bit about the exam too. Okay, and for Manure, I would definitely gonna grant you the access to look up the exam only for one time and see how well that you're able to do on a final exam. Okay, so for the expectation is something that we spend times working on the expected values right here, right? So if we first, you have to make sure that it's follow the something like that. But I'm gonna erase this real quick for that. So that'll be probability times the PI, time the XI. So you have to take the X multiplied by the corresponding probability. So each value is gonna be associated with different chains. So you multiply them and then we add them up at the end. So you're gonna get the expected value, okay? So I hope that's gonna clear all of your confusion, but all right, so I believe that's pretty much the thing that we have here. And then the final exam review is just the thing that I uploaded. And if you have a chance, please look it up and then go to my office hours. So next week, I have it available at 12. And you can just stop by if you have so many questions that you ask before the final exam. So you can just stop by my office hour. I can clear up all the confusion for you. Okay. And still, if there only one person that you come to the office hour, we're gonna spend time working together. But if you more than five, so each person gonna pick me a question. Okay. All right. So I believe that's pretty much it. Any other concern that we have here? You're very welcome. You're very welcome. So, Safir, I'm gonna see you there. And if you have no more concern, if you sort of feel like not happy with the grade because if you think you deserve better, so don't hesitate to email me. I will definitely gonna answer your question. If you feel like, oh, my grade was too high, I can lower the point. You want to? I'm just kidding for that. And I hope that you guys going to a wonderful weekend. I want to start the office hour Zoom real quick for that. For those of you who still have questions regarding a second exam grade, just you know, don't feel shy. Just go there and let me know what it is. Take good care of yourself. I hope that you enjoy my class. And then we're going to see each other again next Saturday. Okay, so next Saturday, I'm not going to do anything. I'm going to just sit in the classroom, not even the classroom, sit on Zoom and then waiting for you guys to ask me a question. Take good care of yourself. Have a wonderful weekend. Bye bye.